Okay, this is the first section of our T.E.A. laser. We have our aluminum plate, our dielectric, which is a transparency film, and we have two smaller aluminum plates on either side. We have our copper bridge with about 20 turns in it. We've got two aluminum tracks which will lay down parallel here, and those two will create our laser track. We've also got two sections here. Each of which has a rounded end that creates the spark gap, which will be positioned about here. It'll bridge between the base plate, the ground plate, and the side plate that'll have the charge. We've got our this is a transparency film, the type that we used. This is our power supply. It's a 2 kilovolts to 10 kilovolt AC power, and we'll dial it down to probably about 5 for the operation of the laser. We'll have the ground end will go onto the base plate, and the power end will go onto here. It'll be far enough away that they won't spark to each other. That'll create a potential between these plates and those plates, and when it sparks here, it'll release the potential along the track. We've been using this multi-tester to determine our impedance on our aluminum tracks and our various parts. We're going to be using lead weights to weight everything down, because obviously you can't screw through anything. We've been using this to cut our cables and strip our cables. So that's step one. Okay, this is T.E.A. laser part 2. We have our laser entirely ready to go. We haven't actually fired it yet, so we're prepping for that. We've got our power supply over here, which is hooked up by these lead weights here. One's on the base plate, the ground plate, and the other one's on the power plate. Notice we've got our spark gap lined up, our aluminum tracks lined up at about 1 millimeter here. The spark gap is about 3 millimeters. We've got a weighted cup here to hold our tracks down. We've got our copper coil across the top to provide inductance between the two. So everything should be ready. We're going to hook our power up. We've got our earplugs and our sunglasses to protect against spark gap noise and brightness. So we should be ready to go. Okay, so this is part 3. We're working on our rectifier to convert our AC to our DC. So we've currently soldered 10 diodes together. Each one can resist up to 1 kilovolt in the opposite direction. So we're soldering 10 together to go up to the 10,000 that our power supply will hold. And we need 4 sets of those in a diamond pattern to create a rectifier. So that's what we're working on right now. We've got our soldering gun and our solder. We've been using these pliers to hold the diodes. So that's part 3.
And there are the diodes.
Okay, this is part 4. We have finished our diode lattice. So we've got our entire rectifier in this square. This is a cathode end, cathode, cathode, anode, 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 cathode, cathode, anode. So essentially you have AC power going in here and there, alternating between the two. And it'll push electricity out here, and it'll pull electricity here, turning your AC into DC. That's part 4, and we'll be adding that to our laser. Right. This is T.E.A. laser part 5. We have now added our power supply with our rectifier to our laser. So we've soldered on, so we've got AC power to either side on our cathode anode joints, and then we've got soldered on there and there wires to our laser. The negative anode end goes onto the top plate, and the positive cathode end goes onto the bottom plate. We have a 1 millimeter gap along our track, so that when the capacitor fires, it'll cross that gap and fire the laser. That's 1 millimeter measured by a credit card, which is surprisingly close to 1 millimeter. And then our spark gap is set to 3 millimeters to fire at a decent rate, also measured with credit cards. So that's laser part 5.
Ready? Stop. Stop.